good morning to all of you. Today we'll go for the topic that is virtualization and common standards in cloud computing. So what is actually virtualization? Then we'll see the example or application regarding to the virtualization, and we'll study the practical part, how to create the virtual machine using virtualization. So we'll study what is virtualization and common standards in cloud computing. So the contents, so first one is virtualization and second part is a common standards. So in virtualization implementation levels of virtualization standards, tools and mechanism, types of hypervisor, virtualization of CPU, memory and IO devices, virtual cluster and resource management, virtualization for data center automation. And in common standard, we have to study the Open Cloud Consortium, Open Virtualization Format, standards for application developers. So browser, in that Ajax, data, XML and JSON. Solution stack, we are using LAMP and LAP. Then syndication. In syndication, we will go for Atom Publishing Protocol and RSS. And last point, we will do the standards for security. So what is actually virtualization? Then common standards for application developer, Ajax, XML and solution stacks. So in this, we are having textbooks. That is, textbook is distributed and cloud computing, from parallel processing to Internet of Things by Jack Dongret. Then chapter 3rd, the reference book is Cloud Computing Implementation, Management and Security by John W. Rettinghouse. So in these two books, we'll find the chapter number 3rd. So what is actually virtualization? So virtualization is a computer architecture technology by which multiple virtual machines are multiplexed in the same hardware machine. So we are having only one hardware machine, that is a host machine, and on that we are creating the guest machine, multiple guest machine. So virtualization is a computer architecture technology by which multiple virtual machines are multiplexed or created in a same hardware machine. In computing, virtualization means to create a virtual version of a device or the resource, such as server, storage device, network, or even an operating system, where the framework divides the resource into one or more execution environment. So more than one environment will be created from the single host machine in the virtualization. So implementation levels of virtualization. So traditional computers runs with a host operating system, specially tailored for its hardware architecture. After virtualization, different user applications managed by their own operating system, we call as a guest OS, can run on the same hardware, independent on a host machine, host OS. This is often done by adding additional software called as a virtualization layer. This virtualization layer is known as a hypervisor or the virtual machine monitor. The virtual machines are shown in upper boxes where application runs with their own guest OS over the virtualized CPU, memory and IO resources. So what actually happens on a single, suppose we consider our host machine is a Windows. So on that we can create the multiple guest machine. The guest machine may have different OS. It can be a Mac OS, it can be Ubuntu, or it can be a Linux OS. So your host machine is your Windows, on which we are creating the virtual machine of different OS. So we are creating the virtual machine. So implementations of virtualization. The main function of software layer for virtualization is to virtualize the physical hardware of a host machine into a virtual resource to be used by the virtual machine. Then it can be implemented at the various operational levels. The virtualization softwares create the abstraction of virtual machine by interposing a virtualization layer at various levels of computing system. Common virtualization layers include the instruction set architecture level, hardware level, OS level, library support levels, and application level. So this is a traditional computer. So what is in traditional? So we will consider different types of hardware. Hardware will be your hard disk may be there, then your motherboard, then RAM, all the hardwares are there. Then this is a host machine, host operating system. Suppose any operating system will be there. It may be Windows, it may be your Linux, and then here having the application. So this is one single computer, traditional computer. Then this is after virtualization. So what we are creating? We are creating a two virtual machines. So guest OS, suppose you are having the example Windows OS here, traditional computer. Now here is a Windows computer, the host OS is a Windows OS. Now we can create guest OS as a Mac OS and guest OS as a Linux or Ubuntu, for example. And then we are creating here application which will run on this OS. Again here, hardware running in the host machine will have the same hardware on your guest machine also. So we are creating here virtualization layer, that is a hypervisor or virtualization layer. So this is how we are creating a virtual machine. So here we have created the two virtual machine. Instruction set architecture level. At the instruction set architecture level, virtualization is performed by the emulating a single instruction set architecture by the single a set of instruction set of architectures of the host machine. For example, if you consider mixed binary code can run on a 86-based host machine, will help on IS emulation. With this approach, it is possible to run a large amount of legacy binary code written for various processes on any given new hardware host machine. Instruction set emulation leads to virtual instruction set architecture created on any hardware machine. The basic emulation methods is through code interpretation. An interpreter program interprets the source instruction to the target instruction one by one. One source instruction may require tens or hundreds of native target instructions to perform its function.